Okay, so we're gonna bring all this stuff together. So we're gonna use everything that we've learned. We're gonna do end behavior. We're gonna use our intercepts, our asymptotes, our holes, and then we're gonna have some test points to figure out what's happening in the zones that we don't already know. Okay, and that'll become clear when you start seeing what I'm doing. So, end behavior. I'm gonna look at my leading coefficients here, or my leading terms. I see that my powers are the same on top and bottom. So I'm going to use the rule that applies to that one, which says I'm going to take the ratio of my leading coefficients. So I've got 3 over 1. So that means my end behavior, as I go to the right, my y values are getting closer and closer and closer to 3. As I go to the left, my y values are getting closer and closer and closer to 3. So that's my horizontal asymptote. Okay, so I can put that down here too. Y equals 3 is a horizontal asymptote. Intercepts. So if I want my y-intercept, that's when x equals 0. So if I put 0 in for x here, this term will be 0, this term will be 0, this term will be 0, and I'll have 35 over negative 25, which is negative 7/5. So that's my y-intercept. So that's the point 0, comma, negative 7/5. To get my x-intercepts, I just want to know when the top is 0. So I'm going to factor, if this thing factors. So to get 35, I can do 5 and 7. If I put the 7 over here and the 5 here and subtract them both, I'll get my negative 26. So I'm going to set each one of these factors equal to 0. So 3x minus 5 equals 0. And x minus 7 equals 0. So I'm going to get intercepts of 7. Right? So 7, 0 is an x-intercept. And this one, if I solved, I would get 5/3. So 5/3, 0 is an x-intercept. Okay, so I've got my horizontal asymptote. I also need any vertical asymptotes that I would have. Vertical asymptotes come from the denominator. Okay, so if I factor my denominator, I get x plus 5, x minus 5. So I have asymptotes at x equals 5 and x equals negative 5. Holes, if I look at my factored version, nothing's canceling out from the top and bottom, so I'm not going to have any holes. If I did end up canceling something here, I'd have to go back and remove it from my asymptote, okay, and make it a hole instead. Test points, we'll look at test points when we actually start graphing. So let's put all this stuff that we've got so far onto our graph. So I've got horizontal asymptote at 3. 1, 2, 3. Okay, there's my horizontal asymptote. I've got vertical asymptotes at 5 and negative 5. 1, 2, 3, 4, 5. And negative 1, 2, 3, 4, 5. Okay, so there's my asymptotes. I've got a y-intercept at negative 7/5, which is 1.4. Negative 1.4. So I'll put a dot there. Negative 1.4. I've got x-intercepts at 7 and 5/3. So 5, 6, 7, there's an intercept. 5/3, which would be 1 and 2/3, there's an x-intercept. Okay. What else? Okay, that's everything. So far, this is all I've got for my graph. Okay, I'm pretty sure I know what's happening in this quadrant, right? Because I've got a point here, and I've got a horizontal asymptote that I have to be approaching, and I've got a vertical asymptote that I have to be approaching. So this one's going to approach that way, and this way. So that's what's happening in this quadrant. I've got 3 quadrants. I've got this area here, I've got the area between these 2 asymptotes, and I've got this area that extends to the left. I've got a couple points in the middle area. I'm still not totally sure what's happening. I know I'm crossing here, and then, somehow these are connecting because these are 2 points. So I'm assuming that this side's going to continue to go down like this because it's not coming back up because I don't have another intercept here. I don't have a 0. And I've only got this one intercept. So I'm assuming it's going to come like this. Okay? Because you're allowed to cross your horizontal asymptotes inside here, and you might even cross them out here. Maybe this comes up and then starts to follow it. It could do that. You are allowed to cross your horizontal asymptotes, but you're not allowed to cross the vertical ones. So I'm pretty sure this is what's happening in here. But to make sure, I'm going to test a point. I'm going to pick like -1. Okay, and I'm going to plug that in to my function. If I put -1 in here, I'm going to get 3 plus 26, which is 29, plus 35, which is 64. If I put -1 in here, I get -24. So 64 over -24, I get this negative number. So it is down in the negative region. I could test 4 and make sure that I'm getting positive out. So if I put 4 and I get positive 48 minus 94, okay, plus 35. And this comes out to be negative, right? Should we just do that? Let's get a calculator here. All right, so I'm going to put in 4. So I'm going to hit 4, store that as x, enter. Then I can just put my whole function in parentheses. This will make it easier for me to plug other points into. 3x squared minus 26x plus 35. Okay, close my parentheses because that seals off the numerator. Then I'm going to divide by, put the denominator in parentheses, x squared minus 25. So I get a positive 2 1/3. So it is up here. Okay, so it's going to follow this vertical asymptote up. And I know that because I don't have another intercept here, so it's not going to come back down and cross again. Plus, this isn't a double intercept, so it's not bouncing there. I also need to test, I don't know what's happening in this region, so I'm going to test a point over here, so let's put -6 in. So in order to do that, I already typed the equation in once. I don't want to type it again. I'm just going to store -6 as my x value. And then I just have to bring up my last entry, so second enter, and that brings it up again. I can enter. I get 27. Okay, so I get a big positive number here. So I'm at -6. I'm way up here. Okay, which means I'm following this vertical asymptote. And then I'm coming down, I'm going to follow this horizontal one. Let's try another number to see if I can get an actual point on here. Let's try something over here, something that'll be closer to our horizontal. So let's put -10 in. -10. Store that as x. And then we'll bring up our function again. I'm getting 7.9, so I'm getting 8. So -10, 3, 4, 5, 6, just about 8. Oops, I need a point. 4, 5, 6, 7, right there. Okay, so it's going to shoot up. It's going to shoot down and keep approaching that horizontal asymptote. So that's my graph. So let's get rid of these brackets here. Okay, so it's not super precise, but it's an accurate depiction of what's happening in the graph. All right, let's do another one. Okay, this one I can tell, so I'm going to look for all the same stuff, end behavior. I'm going to look for asymptotes. I'm going to look for zeros, or intercepts, I'll put. I'm going to have some test points, okay, to figure things out. So my end behavior, I can see that my power on the top is exactly 1 larger than the power on the bottom. So that means I'm going to have a slant asymptote. Okay, which means my end behavior, it is approaching infinity, either positive infinity or negative infinity. But that's going to be dictated by my slant asymptote that I find. So let's find our slant asymptote first. In order to do that, we'll use our long division. So I'm going to do x cubed plus 2x squared plus 4. I'm going to divide by the bottom. So all I'm doing is I'm representing the same function in its divided out form. So I need to match x cubed. So in order to make 2 into 1, I'm going to multiply by a half, and I need another x. So that gives me this x cubed plus half x. And then we're going to subtract this, so change our signs. Okay, now these are x squareds, these are x's, so they don't match up. So this is just going to come straight down and stay as 2x squared minus the half x. Now this already matches it, so I'm just going to multiply by 1, which gives me 2x squared minus 1. Okay, and let's bring the 4 down, because this doesn't match up when I switch my signs. These will cancel. This is going to combine with this, so I'm going to have negative 1/2 x plus 5. Now, this is my remainder. So, since our asymptotes are only what's happening as x gets very large, the remainder doesn't matter, because the remainder is going to become 0 as we get closer and closer and closer to a large x value. So this is the equation of my slant asymptote. So y equals 1/2 x plus 1. So I'm going to graph that as a slanted line, and that's what my graph's going to approach as I go towards the right and towards the left. Other asymptotes I would have, I'm not going to have any vertical because this only yields imaginary numbers when I set equal to 0. So there's no vertical asymptotes. There's no horizontal, so this is the only asymptote I have. Intercepts, I have to figure out when the top is 0. And since the top is a cube, I'm going to graph it. So I'm going to have x cubed plus 2x squared plus 4. It's crossing right there, which hopefully is a half number. Or no, it's not a whole number, and it should be. So let's calculate that. Calculate a 0. I want to know where this thing is. It's at negative 2.59. So that's where my 0 is going to be. So intercept, my x-intercept is negative 2.59, comma 0. Okay, so we've got our slant asymptote, we've got our x-intercept, we can find our y-intercept by plugging 0 in, so 0, 0, 0 turns into 4 over 1. So it's my y-intercept. So x is 0, y is 4. And now let's just start plugging in what we've got into our graph. So we have a slant asymptote of 1/2 x plus 1. Let's move this down here and make it a little bigger. So 1/2 x plus 1. That means I've got y-intercept of 1. I'm going up 1 over 2. Up 1 over 2. Okay, I want to go the other way with it also. my slant asymptote. Put a couple other points in here so we can see a little better. Okay, there's my slant asymptote. I've got a y-intercept at 4. 1, 2, 3, 4. I've got an x-intercept at negative 2.54. So negative 1, 2.5. So it looks like this is already approaching my slant asymptote as I go this way. I'm not sure what's going to happen over here, but I know it's eventually going to have to come and approach this way. So let's use a test point. I'm going to put in 5. Let's see what happens when our function is 5. So if I put 5 in here, I'm going to get 125 plus 50 plus 4, which is 179 over, I would get 51, which is 3.5. Okay, so I'm at 5, I'm at 3.5. 1, 2, 3, 4, 5. 1, 2, 3.5. Just above 0.5. So I'm right there, so it's already approaching the asymptote also. So it's kind of a goofy looking graph. Okay, I'm approaching my asymptote. Gonna bump up a little. And I come back down and approach. Alright, let's check it. Make sure I did it right. So, put parentheses around the numerator. X cubed plus 2x squared plus 4 divided by the numerator or the denominator, which needs to be grouped. 2x squared plus 1. Yep, and that's pretty much what I have. Okay. So, fairly accurate graph. Okay, so that's all I have for the full spectrum of graphing equations. So just remember, you've got to find all these things. Some of them you'll have, some of them you won't have. I didn't have any holes in this one, or the other one actually, no holes. But a hole, if I had one, let's say there was a hole, at this x value, I'd just draw a hole right there on my graph. So end behavior, intercepts, both x and y intercepts, asymptotes, holes, and then some test points to help fill in the graph's behavior.